Hello! In this video, we are going to prove the following theorem. For all complex numbers z and w, the sine of z plus w is equal to sine z cosine w plus sine w cosine z. And the cosine of z plus w is equal to cosine z cosine w minus sine z sine w. So, let's first remind ourselves of our definition of sine and cosine. For each complex number z, we define the cosine of z to be e to the iz plus e to the negative iz over 2, and we define sine z to be e to the iz minus e to the negative iz over 2i. Now, at this point, we have proven Euler's formula, that is, for all complex numbers z, e to the iz is equal to cosine z plus I sine z. We've also proven that cosine is an even function and sine is an odd function. That is, for all complex numbers z, the cosine of negative z is equal to cosine of z, and sine of negative z is equal to negative sine of z. Okay, so now let's get into proving this theorem. To start out the proof, let's first give ourselves two arbitrary complex numbers, z and w. And now, let's first prove the sine addition formula. Now, by definition of sine, the sine of z plus w is equal to this, right? So all we've done here was we substituted z for z plus w. And now we're going to re-express the numerator in a different way. First, let's distribute the I across this parentheses, and let's distribute negative I across this parentheses. And now we know from properties of the exponential function that this is just equal to this. But now we can apply Euler's formula. In doing so, we know that e to the iz is equal to cosine of z plus I sine z. E to the iw is equal to cosine of w plus I sine w. And actually, we can also apply Euler's formula to e to the negative iz and e to the negative iw. Because we know that e to the negative iz is equal to e to the I times negative z. So then, by Euler's formula, e to the I times negative z is equal to cosine of negative z plus I sine of negative z. And similarly, e to the negative iw will be equal to cosine of negative w plus I sine of negative w. But now, since cosine is an even function, we know that cosine of negative z is equal to cosine of z, and cosine of negative w is equal to cosine of w. Further, since sine is an odd function, we can pull the minus sign out to the front, and we can pull the minus sign out to the front. So we have this. And actually, since I didn't put parentheses around the arguments here, I'm going to just get rid of the parentheses here as well, just for consistency. So we have this. But now, let's expand this out. So if we multiply these guys together, we get this. But then we are subtracting these guys. And if we multiply these guys together, we get this. Now, we know that plus I squared is really just minus 1, and plus I squared is just minus 1. So now, we're going to drop the parentheses here, and we're going to distribute the minus sign across this parentheses. And we get this. Now notice, the cosine z cosine w cancels out, and the sine z sine w cancels out. And we also see that I sine w cosine z combines together, and I sine z cosine w combines together. So we get this. And what this tells us is sine of z plus w is equal to this guy over 2i. And now we see that the two i's cancel out, and so we are left with this. So we have proven the sine addition formula. Now let's prove the cosine addition formula. Now, by definition of cosine, the cosine of z plus w is equal to this. And now we are going to re-express the numerator in a different way. First, let's distribute the I across this parentheses, and let's distribute the negative I across this parentheses. And then, by properties of the exponential function, we know that this is equal to this. But then, we apply Euler's formula. By Euler's formula, we know that e to the iz is equal to cosine z plus I sine z. E to the iw is equal to cosine of w plus I sine w. But then, just like we did before, using the fact that cosine is even and sine is odd, we have that e to the negative iz is equal to cosine z minus I sine z. E to the negative iw is equal to cosine w minus I sine w. Right? So now let's expand this out. If we multiply these guys together, we get this. But then if we expand this out, we get this. And we know that I squared is just equal to negative 1. So this just becomes a minus sign, and I squared is equal to negative 1. So this becomes a minus sign. And at this point, we could actually drop the parentheses, but I'm just going to keep them just so it hopefully looks more readable. But now, we see that some things cancel out. First of all, I sine w cosine z cancels out. I sine z cosine w cancels out. We also see that cosine z cosine w combines together. And minus sine z sine w combines together. So we get this. And now we see that cosine of z plus w is just equal to this guy over 2. And we know that the 2's cancel out, so we are left with this. So we have proven the cosine addition formula. And so this completes the proof. And so yeah, that's pretty much it for this video.